Welcome to lecture on game theory. This theory was given by von Neumann in 1928. He is also called as father of game theory. But it was in 1944 this theory got attention because of the publication called Theory of Games and Economic Behavior by von Neumann and Morgan Strain. We understand what the games are. We know various games like cricket, football, chess, and so many others. But there are many other games which we have not seen through the perspective of game. So game needs to be defined so as to understand many situations as game. It's not just that football, cricket, chess, and so many things which we understand as game are the only games, right? So for that, we need to understand what are the various characteristics of the game. We need to define game. So game is defined as any competitive situation is called as game if it has following properties. For example, the first property that there should be finite participant n. Uh, n must be greater than equal to greater than 1. There must be more than one participant in the game. If there is only one participant, and if you claim that what is being done by that one player is a game, then it is wrong. It's not the game. For example, a solitaire. It is an arrangement. You do certain arrangement of the stack of cards, shuffled stack of card, and you then try to rearrange the cards in a specific style, and you call it solitaire. You must have played solitaire game on computer, and if you claim that the computer is another participant and the one who is playing with the computer on the computer, that solitaire game is another participant, then it is wrong. Okay, participant is the one who participates into the game. Computer is just presenting you the stack of cards in a specific arrangement, and it is only you who is playing solitaire on computer is doing everything. Computer is not doing anything in response to what the player playing the solitaire on computer is doing, right? So there is in fact only one player, and in that case we do not say that it is a game. Okay, for something to be a game, it has to be competitive situation. There has to be the objective of winning, and if there is only one participant, then it is not a competitive situation. There has to be more than one participant. So that is the first property to be observed to call something as game. Then second, each participant has finite number of courses of action. Finite number of courses of action are available to him, right? Again, when we are going to do certain mathematical analysis, it is necessary to specify whether something referred is finite or infinite. So any participant involved in the game won't be having infinite number of courses of action. He will be having finite number of courses of action, and then associated with each course of action there will be finite gain, right? There can't be infinite gain associated with certain course of action. If that happens, then the game will be monopolistic game, right? If any course of action, suppose say gains infinite thing to some of the participant, he only will be winner, and in that case, the game won't be a competitive situation. So once again, covering all the three which we have seen so far, the first, the number of participants must be greater than one. There must be more than one participant, and the number of participants is always finite. Each participant has finite courses of action available to him, and associated with each course of action, there is finite gain. Okay, and then now the game starts. After this much of the setting in terms of participant, what the participant has, that is number of courses of action he has, and he associated with each course of action, or each course of action exists for providing the finite gain, right? Then a play of game is said to have occurred or said to occur if player selects his course of action or some course of action amongst many available to him. Play of game is said to have occurred or is said to occur if player select one course of action or his course of action. The gain to the participant depends upon the course of action selected by him as well as course of action selected by other participants, other players, right? Participants in the game are called as players, right? So play of game is said to have occurred if certain participant in the game select certain course of action, and the gain to the participant depends upon the choice of course of action he has made and the choice of course of action other participants have made, right? Each player know what course of action will be selected by other players soon he select his own course of action, right? Each player knows what course of action will be selected by other players soon he selects his own course of action, right? This is little tricky to understand in the perspective of the games which you normally play like cricket, football, right? Every player, in fact, knows what will be the course of action selected by the player. Soon he selects his own course of action. This is better understood if you think of the game of chess. Soon one thinks or one plays one certain instrument of the game. He knows what will be played, what will be moved by the other participant, right? Right? Then sum of gains of all the players is zero, right? For example, in a game of football, if some team wins by 3 goals, the other team also lose by 3 goals only. So if I make the sum of wins of all, okay, one team has won by 3 goal and other team also has won by -3 goal. Last we will be telling in terms of win, and that time I will have to use -3 in place of 3. So sum of the wins of or sum of the gains of all the player is zero, and therefore the games are called as zero sum games. Okay, if there are n participants in the game and we know that the sum of the gains of all the player is zero, the game is called as n person zero sum game, right? So these are all the characteristics which will be making any situation as a game. Okay, if any situation, any competitive situation is having these 6 characteristics, then we can call it as a game. So everything we know as a game will be satisfying these 6 characteristics. Okay, and there are many other things which we don't know as a game, but now because they follow these 6 characteristics, we can call them as a game. There are many games in management, marketing management. There are many companies who are trying to gain maximum market share. There are many companies who are trying to get maximum market share. So there is a competitive situation. There are more than one player. Each player each participant has finite number of courses of action available to him. Associated with each course of action, there is finite gain. If you think of that situation, marketing situation, and the play of game is said to have occurred if the player selects his course of action. He may provide discount, or he may provide some gift with the item which he is selling. Okay, and in response to that, the competitor also will be doing something, and what he will be doing is known by the player who selects his course of action, right? So this characteristics is very important. Each player know what course of action will be selected by other players. Soon one selects his own course of action, right? This this fifth characteristics agrees that every participant in the game is intelligent enough. Is intelligent. Okay, so if the player is not knowing what course of action will be selected by other player in response to selection of course of action made by him, then we will not consider him to be the intelligent player, right? So these six characteristics, these six properties can bring many situations in the domain of gain, and that makes this theory very interesting. And another thing which makes the analysis interesting is the presentation of game. Okay, because of the presentation of game, it becomes easy to understand the game and do the analysis of the game. All right. So here the presentation of we will be limiting our discussion just to two participants, two players. Okay. So with reference to two persons, the game can be presented which is more visualizable, right? And this theory can then be extended to multi-person zero-sum game, right? So we'll be limiting all our discussion to two-person zero-sum game, right? The presentation of the game is important so that we are able to analyze it and understand the things and take the things further, right? So there are two players in the game. One player will be calling as A and another player will be calling as B. Normally, the player which is positioned here, you understand that that is you. Unless you put yourself into game, it will be difficult for you to understand the game theory. Various principles used in the game theory. So let us position yourself in this position. This is you and this is the competitor, right? Now there are two players. The first characteristic is satisfied, first property. Then each player has finite courses of action available to him. So player A has three courses of action. What are these? Let this be some situation in end game of the chase, right? And in end game, because of the limited instruments available, there are limited moves. Okay, so in certain situation of the game, there are three courses of action available to player A, and what are those? One is move rook 2, some specific moment of some specific move of rook 2. That is one course of action. Then another course of action available to player A is move of pawn 6. Okay, some specific move of pawn 6. And third course of action, just to give you an example, is some specific move of a queen. Okay, and player B has the courses of action like move some specific move of knight 1, right? And player B has another course of action move of some specific move of rook 1, right? So we have nomenclated them, this all the courses of action, we have nomenclated them as B1, B2 for player B and A1, A2, A3 for player A. Right? Now, if player A plays, say, knight 1, the specific move of knight 1, and in response to that, player B plays B1, that is, I'm sorry, player A plays rook 2, and in response, player B plays knight 1, then player A will be gaining -4 points, -4 points. And if player A plays rook 2, and in response to that player B plays rook 1, player B plays B2, that is rook 1, then player A will gain 4 points, right? So I will now make the thing simple. I will not be referring to this specific moves. Okay, this was just taken to make you understand this thing as a game. In the perspective of game, you can understand the things better. Now, this moves I'll be referring by their nomenclature done A1, A2, A3, and for player B, B1, B2. Now, if player A plays A2 and in response player B plays B1, then gain to player A will be -3. Likewise, in response to player A's play A2, selection of course of action A2, player B selects to play B2, then gain to player A will be 5 and loss to player B will be 5. Whatever player A gains, equivalent is the loss to player B. Okay, that you must understand. What one gains is the loss of another. Right? If player A plays A3 and in response to that play of player A, player B plays B1, then A will gain 3 and B will lose 3. Right? And if in response to player A's selection of course of action A3, player B selects to play B2, then player A will be gaining 4, winning 4, and player B will be losing 4. So this matrix is called as payoff matrix, and through the point of view of player B, all these values are loss values. And through the point of view of player A, all these values are gain values, win values. That's why I wanted you to assume this player as yourself. You are the winner. You won't assume yourself in loser's position. So this is your position. Okay, and you are going to win. Okay, so this matrix through the point of view of player A are the gains, and through the point of view of player B are the losses. That is very interesting presentation of the game. Okay, and the matrix is called as Payoff Matrix. I hope you have understood how to read the game. Okay, so for example, if you once again come at this value, so this value can be referred as gain to player A or loss to player B if A plays A2 and B plays B2. Alright? If I ask you what is the gain to player A, if player A plays A3 and B plays B1, then your answer should be 3. Right? Gain to player A will be 3. If I ask you what is the loss to player B, if player B plays B1 and player A plays A2, so loss to player B will be -3. Okay, so you must understand how to read the game. Now, having understood how to read the game, we will start doing our analysis. Okay, now what will be the minimum guaranteed gain to player A if he plays A1. If player A plays A1, what is the minimum guaranteed gain? Okay, now we know very well that player B will be playing that course of action, playing which will result in minimum loss to him, because he will always be playing to minimize his loss, and player A will be playing to maximize his win. Actually, mathematically, we can equate loss to win, but for that we will have to give negative sign to win. Negative win is a loss and positive win is a win. Okay, right? So this is for in physical terms we use the terms like win and loss. Mathematically it is win and minus win. All right. So anyway, if player A plays A1, then player B will be selecting to play that course of action which results in minimum loss to him, because player B is playing for minimizing his loss, right? So what course of action will be selected by player B? Course of action selected by player B will be B1. Why? Because playing B1 results in minimum loss to player B. Okay, and soon player B selects, because he is intelligent, player B will be selecting to play B1. Okay, and loss to player B will be -4, and same will be the gain to player A. Okay, player B will not be playing B2, because player B knows if he plays B2, loss to player B is 4, that is more. Okay, and player A also knows in response to course of action A1, player B will be playing B1 only. That is what is said in the fifth property of the game. Each player knows what course of action will be selected by other player. Soon he selects his own course of action. Right now that player A has selected to play A1, he knows that player B will be selecting to play B1. Okay, and minimum guaranteed gain to player A is -4 in that case. All right. Now, if player A selects to play A2, right? Player B soon immediately will be selecting to play B1. Why? Because in playing B1 in response to course of action A2 selected by player A, the loss to player B is lesser, -3 is lesser than by playing B2. If player B selects to play B2, loss to player B will be 5, and that is more. Okay, so player B will be selecting to play B1 in response to course of action A2 selected by player A, and therefore the minimum guaranteed gain to player A will be -3. Mathematically, what we are doing, we are finding minimum value in each of the row and writing here, right? That is minimum guaranteed gain. We hereafter will be calling that as MGG, minimum guaranteed gain. Whenever we talk about gain, it is safe to talk about minimum guaranteed gain. Come second, minimum, this will be the gain to the player. Okay, and when we talk in terms of loss, we use the object adjective maximum possible loss. Okay, so minimum guaranteed gain is the safe term to think about gain, and maximum possible loss again will put you in safe position when you are talking about loss, right? So minimum guaranteed gain if player A plays A3 will be what? 3 here, because player B will be selecting to play B1. Alright. He will not be selecting to play B2 in response to course of action A3 selected by player A. Now that we have thought in terms of the minimum guaranteed gain to player A, if he selects various courses of action A1, A2, A3, we can as well think about our competitor player because all the values are in front of us. Okay, so if player B, suppose say selects to play B1, what will be the choice of player A? Player A will select that course of action, selecting which will result in maximum gain to player A and equivalently maximum loss to player B. If A gains more, B lose more. Simple formula. Alright. So if B selects to play B1, A will immediately select to play A3, course of action A3. Because A will always be trying to play that course of action which results in maximum gain to him. Maximum gain. A is for winning maximum and B is for losing minimum. Okay, so player A will be selecting to play A3. Okay, and by selecting to play A3 in response to course of action B1 selected by player B, gain to player A will be 3 and loss to player B will be 3. So maximum possible loss to player B is 3, and by if player B selects to play B2, then maximum possible loss to player B can be found out by simply finding maximum value in this column, and that you write here. Okay, you can associate with the physical happening if player B selects to play course of action B2, immediately player A will be selecting to play course of action A2. Why? Because he wants to maximize his gain. Okay, soon player A selects that course of action, loss to player B is well known, that will be 5. Okay, all in all, when you think of rows or think of player A or player, it will not be always a player here, you will be finding minimum value in each of the row that will be standing for minimum guaranteed gain to player A. Okay, whenever we talk of player A, which is written here, okay, we will be interested in minimum guaranteed gain, and when we talk of player B, which is written here, we will be talking in terms of maximum possible loss. So in each of the column you find maximum value and write here. Now that you know what is going to be the minimum guaranteed gain for player A by selecting various course of action, now the question obviously will be which course of action to select, which course of action will be selected or preferred by player A. Player A will be selecting that course of action which results in maximum of minimum guaranteed gain. Okay, player A knows that by playing A1, the minimum guaranteed gain is -4. By playing A2, minimum guaranteed gain is -3. By playing A3, minimum guaranteed gain is 3. So maximum amongst the minimum guaranteed gain is 3. So I round this. Okay, this value I'll be calling as maximin. It is maximum of minimums. Maximin, right? And then we will be doing the analysis through the point of view, we'll be doing the predictions about what player B will be playing and what is going to be the last to player B. Okay, so player B will be playing which course of action? He will be playing that course of action, playing which will result in minimum of the maximum possible loss. Okay, he knows by playing B1 the loss is 3, and by playing B2 loss is 5. So he obviously will be playing B1 because He is interested in minimizing the maximum possible loss. So this value is called as minimax. Minimum of maximums. Minimax. Okay. Now here I am finding that maximin is equal to minimax. Okay. Maximin is equal to minimax, and when that happens, right? When that happens, the game is balanced. The game has saddle point. When minimax is equal to maximin, when minimax is equal to maximin, all right, I say that game has saddle point. It is balanced game. Okay, game has saddle point. All right. And game is solved there itself. I know very well what will be played by player A and what will be played by player B. Right? I know the proportion in which course of each course of action will be used by player A or player B is called as their own strategies. Like for example, if I want to talk about strategy of player A, strategy of A. So player A will be playing A1 0 times. He will be playing A2 never, and he will be playing A3 always. Okay. And strategy for player B, strategy of player B, the proportion in which each course of action is played. So B1 will never be played. Okay, yes, it will always be played. B1 will always be played because this is minimum of maximums. And you know very well, the B1 will always be played and B2 will never be played. Okay. So by now you have understood various terms like player. Player means the participants involved in the game. Then courses of action you have understood various moves which each of the player can use are called as courses of action. Right? Play you have understood. Now strategy is nothing but the proportion in which each course of action will be selected by player A and player B, right? And lastly, one term is important: game value. Okay, game value V. Okay, game value V is the average winning or losing over long number of plays. Now suppose say this game is played just one move by player A and one move by player B. Okay, what is the gain to player A? Gain to player A is 3 and loss to player B is 3. Now if this happens twice, then the gain to player A will be 6 and loss to player B will be 6. If this happens thrice or 10 times, then what will happen? Gain to player A will be 30 and loss to player B will be 30. This is very important thing in the game. Whatever is the gain to player A must be equal to loss to player B. Because you see in various game which you play, by whatever amount, by whatever extent, one player wins, second another player loses by same extent. Okay, that makes it a game, right? If it so happens that one player has won by 3 points and another player has lost by 2 points, then we will be saying that there is some problem in the game. It is not the game at all. In game, it will definitely happen that by whatever extent one player wins, another player lose by same extent. Okay, so you have to take all the care in the game that the extent of winning of one player is equal to extent of losing of another player. Okay, so play this strategy will, you have to form the strategies for player A and B by which the winning of player A is ensured to be equal to losing of player B, right? And that average winning or losing over long number of plays is called as game value. Now, as I have given just the example, if this game gets played for 10 times, gain to player A will be 30 and average gain to player A will be 3. And loss to player B will be 30 and average loss will be 3 again, because this game is getting played for 10 times. So average winning or losing over long number of plays is called as game value. In this case, it is very simple that it is minimax or maximin itself. Okay, when minimax is equal to maximin, then game value is equal to either minimax or maximin. So game value in this case is 3. Okay, this game was very simple to solve. Why? Because it was just the starting game, and I cannot make your starting game difficult for you, right? So whenever the game has saddle point, game value is very simple. It is minimax or maximin, and strategy writing strategies uh, is also simple, right? In this case, we say that both the player are using pure strategy. Pure means any of the player is using only one course of action. Okay, both the player are said to be using pure strategy. Player A is not using A1, not A2, he is purely using A3, and player B is not using B2, he is purely using B1. Okay, right? So now we will sometime ahead coming across the case of mixed strategy. This is pure strategy because both the players are using only one course of action, but you know that many times multiple courses of action are to be used in real games. Okay, we'll be coming across that, right? Having understood this, right? Uh, we will be seeing reduction of game by dominance principle. But before we go to that problem, we have to understand, we have to again recite this thing to ourselves every time, that A is a winner player, he will try to win maximum. B is a loser player, he will try to lose minimum. I have positioned B here. But if B is positioned here, B will have to be considered as winner player. So position decide who is a winner player. Okay, whatever is written here is a winner player. So we will always be assuming that this is A for our convenience of my convenience of explanation. I'll always be taking player A here and B here. You, however, go by position. Alright? So player A is winner and he will always try to win maximum. Player B is loser. He will always try to lose minimum. Okay. So we will be finding, but whenever you are analyzing on the course of action B1 and B2, you will be finding maximum possible loss. But when you will be thinking on the gains of A1, A2, gains due to course of action A1, A2, A3, you will be thinking in terms of minimum guaranteed gain, right? So you did here, then you will be finding maximum of minimum guaranteed gain, and here also you will be finding minimum of maximum possible loss. If maximin is equal to minimax, you got the saddle point, and once you get saddle point, game value is equal to maximin or minimax, and then Strategy for player A is pure strategy, like declared here. Whatever um, thing is around it, the course of action associated with that will always get played. So my strategy for player A is 0-0-1, and strategy for player B is 1-0. Now, that principle that A is winner and B is loser, we will practice here in this big game, right? Once again, reciting or going through recalling all the properties of the game, right? So here there are two participants. That was the first property. Player A has finite courses of action available. Player B also has finite courses of action available. Associated with each course of action, there are finite gain. Okay. For example, A1. Associated with A1, the gains are 4, 2, 0, 2, 1, 1. All these values are finite. Nowhere there is infinite value. Okay. Then the next property was that player A may be selecting to play any one of course of action, but what he will be gaining is will be decided by his choice, not only his choice, but the choice made by other player. Okay, that we have just discussed. All right, and now uh, before we reduce the game by dominance principle, we will be just finding out minimum guaranteed gain and maximum possible loss. If the game gets solved so easily as our earlier game got solved, okay, very easily it got solved, we'll be looking into the possibility of solving the game that easily. Okay, so we will be finding out MGG, that is minimum guaranteed gain and maximum possible loss. Alright, so here I go. MGG, minimum guaranteed gain. Alright, so minimum value in that row is 0. Then minimum value in the second row is 1. Then third row is again this is -5. Minimum value in this row, fourth row, corresponding to course of action A4, is -1. Then minimum value corresponding to fifth course of action is -2. All right. So amongst all these minimum values, I will be finding maximum one. That is, this maximum value is this one. This is maximin. Then I'll be finding out maximum possible loss for each of the course of action of player B. The maximum possible loss to player B if he plays B1 is 4. Maximum in this column. Maximum in this column is 3. Maximum in this column is 7. Maximum in this column is 3 again. Maximum here is 2. Maximum here is 2. So amongst all these maximum possible losses, I have to find minimum of maximums, maximum possible loss. So minimum is this two or this two. You may round any one of these two. So this is what? This is maximin. Alright? This is minimax. This is minimax. And what you are finding here, maximin is not equal to minimax. Okay. So here I write maximin is not equal to minimax. Alright. Maximin is not equal to minimax. So game doesn't have saddle point. No saddle point. What does that mean? There won't be pivot strategy. That means both the players will be using multiple courses of action. But this game is little big to do the analysis. Okay, if it is possible for us to reduce some of the courses of action, that is, we will be getting less size matrix, which will be manageable, right? This is not unmanageable, but if it is possible for me to eliminate some of the courses of action for both the players, then the size of the matrix will reduce, and it will be convenient for me to proceed ahead with that reduced size matrix. So what we will be doing now, simple principle of selection. Suppose say you think of the game of cricket. There are three faculties based on which the selection of the player is done. Now, suppose say there are two players amongst which I have to select one. So, and if one player is better than another player in all the three faculties of the game, that is, one player is better in bowling, he is better in batting, he is better in fielding than another player, then obviously this first player will be my choice, and second player won't be considered. Okay, so if in all the faculties one player is better than another, he will get chosen. He will be selected, right? Other will be rejected. Other will not be considered. Okay, but the choice becomes difficult if one player is better than another player in batting, another player is better in bowling, and both the player are at par in fielding, then the choice becomes difficult. Okay, it's not straightforward. So same principle of dominance we will be using here, right? Now just look at player A. Player A has various gain values starting from 4 to 0 to 1 1. Now I compare all these gain values, okay, with the gain values if player A choose to play A2. Okay, gain values are going to be 4 3 1 3 2 2 depending upon the choice made by player B. So I can compare these two gain values, win values for player A. Okay. So both these values are same. So I'll go ahead. Here I am finding that this is more gain. Here again this is better gain. If player A selects to play A2, the gain is better than if he selects to play A1. Let's proceed ahead. Again, if player B plays B4, still player A gets better gain. Okay, that is 3. If player B selects to play B5 and player A selects to play A2, the gain to player A is 2, as against if the player would have selected to play A1. Okay, so gain by playing A2 is more than by playing A1. So again, here also gain to player A is more if he plays A2 as against A1. So we are finding that all the gain values for course of action A2 are better as compared to gain values for course of action A1. So in the presence of A2, A1 will never be played. Okay. So if it is never going to be played, then what we may do, we can eliminate A1. Okay, because it is not going to get played, so we can eliminate A1. It will never be used. I will be eliminating A1. Alright, so here I write dominated. Okay, here I write dominated by A2. Course of action A2. In presence of A2, A1 will never be played. Now compare A2 with A3 because A1 has gone. So there is no point in comparing A1 with A3. The thing which has gone doesn't need to be compared with any other course of action. Now compare A2 with A3. So these are equal, these are equal, this is more and this is less. So the consistency in the relationship is lost. Then you leave the comparison ahead. Right, because this was more, till this point it was equal, so this was more. I expected that this value to be more than this. Had it happened, then I would have considered, I will have continued the comparison ahead, but soon the consistency get lost. I stop the comparison. Then what I do, I compare A2 with A4. Now these values are same, this are same, this is more, this is lesser. So I don't compare it ahead. Okay, dominance principle works only if all the values in one row are greater or lesser than all the values in another row. Okay, then compare A2 with A5. This is equal, this is equal, this is higher, this is lesser. Okay, so there is no point in continuing the comparison ahead. Now compare A3 with A4. This is equal, this is equal, this is lesser, and this is higher. This is minus 1 is higher than minus 5, right? So the comparison is changing. Okay, it is flipping. So there is no point in continuing the comparison ahead. Now compare A3 with A5. Okay, this 4 4 equal 3 3 equal 7 3. 3 is lesser, all right. Then minus 5 and minus 2. Minus 2 is greater. So there is no point comparing ahead. Now compare. Now that A3 has been compared with each of the course of action ahead. Okay. So I now need to compare A4 with A5. Okay. So 4 4 equal, 3 3 equal, this is lesser, this is also lesser, minus 2 is less than minus 1, this is equal, this is equal. So what does that mean? In presence of course of action A4, A5 will never be used. Why? Because A5 gets you lesser or equal gains as got by playing a poor course of action by player A. So in presence of A4, A5 will never be used. So I can eliminate that also. Okay, A5 I can eliminate, right? A5 I can eliminate, and here with remark that dominated by A5 dominated by A4. That's why I have eliminated. Now I am left with, player A had 5 courses of action available. Now it is left with just 3. Player B also had 6 courses of action available. Now I'll be thinking through the perspective of my competitor by player B. So what I'll be doing? I'll be doing the comparison in between the live values which are still remaining for player B. That is in rows A3, A2, A3, A4. I won't be comparing these values. So here I go, B1 I compare against B2, this is more, this value is lesser, this 3 is lesser than 4, 3 is lesser than 4. So all the values in B2 column are lesser than B1 column. Now the consideration is through the point of view of player B. Okay, B will try to retain that course of action which results in minimum loss to player B. Whenever whenever we are referring to B, we must think in terms of loss, and whenever we are referring to A, we must think in terms of gain. So player B will retain that course of action which results in minimum loss, lesser loss, and eliminate that course of action which results in more loss. Okay, so these all values are more. Okay, I'll be cancelling right from this end, or let us do only till this. Okay, doesn't matter if I complete the column. So because I want something to write there, player B will never be using B1 because that results in more loss to player B. Okay, player B will never be using B1 in the presence of B2. Okay, so here I write dominated by what, B1, dominated by B2. Sorry. Right, now B2 I'll be comparing with B3. All right, so this 3 1 1 is lesser, 3 7 7 is more, so I won't continue the comparison ahead and I'll save my time. B2 with B4, 3 3 equal 3 minus 5. Okay, as compared to this, minus 5 is lesser. 3 and minus 1. Minus 1 is lesser. Okay, so B4 is resulting in lesser losses as compared to incurred by selecting course of action B2. So in presence of course of action B4, B2 will never be used. All the values in B4 column are lesser than all the values in B2 column. Okay, live values I am talking about. Okay, cancelled values I am not comparing. I am not considering cancelled values. I will be comparing and considering the values which are not cancelled. Mhm. Right? So here I player B will not be playing B2 when he has B4 available. So I'll be cancelling this also. Okay. So with the remark that, what is the remark? Dominated by B4. Dominated by B4. Right? Then I'll be, now there is no need of comparing B2 with anything else because that itself is cancelled. Now B3 with B4. So what I'll be doing, this is more, 1 3 3 is more, 7 and minus 5 is less. No point in carrying out the comparison ahead. Now B3 with B5, 1 and 2, 2 is more, 7 and 1, 1 is less. So no point in comparing the things ahead. Okay, then B3 with B5, 2 1 and 2, 2 is more, 7 and 2, 2 is less. All right, so no point comparing ahead. So now I'll be comparing B4 with B5, 3 2, 2 is less, minus 5 1, 1 is more. Leave the comparison. B4 and B6. All right, so 3 and 2, 2 is less, minus 5 and 2, 2 is more. Leave the comparison. Okay, then compare B5 live values against B6 live values. 2 2 equal, you can continue ahead. 1 and 2, 2 more, this value is more, and again lastly 2 2 equal. So now player B will never be playing B6 because playing B6 will be resulting in more loss as compared to incurred by playing B5. So what we will be doing, will be cancelling B6 column for player B, and here I have the remark dominated by, dominated by uh, what, here I can write dominated by, why I have cancelled this, because it was dominated by B5. Okay, mostly this is obvious. I have explained it little longer, but you just based upon this principle that player B will not be using that course of action which results in more loss, and player A will not be using that course of action which results in lesser gain. On that principle you can work on it ahead. Now this 5 by 6 matrix is reduced to how many columns are rows are remaining? 3 rows and 3 columns. I will once again be coming on to the live rows. I'll be comparing live rows because might be the thing which had came in the way of dominance have got eliminated. I will be taking one more chance of comparing the elements live in the rows. So let us compare 1 and 7. 7 is more. 3 and minus 5. Minus 5 is less. So leave the comparison. Compare this with this. A3 with A2 with A4. 1 and 4. 4 is more. 3 and minus 1. Okay. Minus 1 is less. Okay. So don't no comparison ahead. Then A3 with A4. 7 and 4. 4 is less, minus 5 and minus 1. Minus 1 is more. So leave the comparison. Among the row, no row is dominating another row. Let's look at the columns. Columns we have just seen, but let us take one more chance before we finalize the reduction by dominance principle. Compare this with this. Okay, I think we have already done this, but still, this is more, this is lesser. Leave the comparison, compare this with this, right? This is more, 7 and 1, 1 is less. Then compare this with this. 3, 2, 2 is lesser, minus 5 and 1, 1 is more. So you finally are left with 3 by 3 matrix which cannot be reduced further. So that final matrix I will be writing here, which is to be analyzed further. Okay, but the trouble of working with 5 by 6 has reduced to working with 3 by 3. Right? Right now, we will be closing this problem here. Okay, we'll be seeing how to solve this problem but later after covering some more algorithms. So I am left with what is that? A2, A3, A4. A2, A3, A4. And what are the what are the courses of action which are still live? B3, B4, B5. B3, B4 and B5. And the values I simply have to copy 1, 3, 2, 7, minus 5 and 1, and lastly 4 minus 1, 2. Okay. How to solve this game ahead? Because see, if I think of finding MGG and MPL, maximum possible loss, there is no point in doing that. Why? Because this one thing I forgot to explain you, but that I'll be doing now. Maximin is not equal to minimax. Had it been, then the game value would have been minimax or maximin, because if they are equal, then that will itself be game value, right? But if they are not equal, then one thing is very clear, that minimax will always be greater than equal to maximin. This value which appear here, okay, will always be greater than the maximum value which appear here, okay, or all the values which appear here. All these values will be sorry, maximin will always be less than minimax. Okay, so game value, what then will be the game value? game value in this case will be lying between 1 and 2. Had both been equal, then it would have lied between this value and this value. As both are equal, game value will be that value itself. But if they are not, then game value will lie between maximin and minimax. Here too, if you try to find MGG and MPL, let's do for your sake, for your satisfaction. Okay, MGG, this is actually not needed to be done, but I just want to establish one thing, that it is not much needed. Okay, so A2 minimum guaranteed gain here is 1, here is minus 5, and here is minus 1. A maximum possible loss is what, that is 7. Here it is 3, and here it is 1. I'm sorry, 2. Okay, this is maximum of minimums, and this is minimum of maximums. This is still 1 and 2. If we knew that this game has doesn't have saddle point, this also will not have saddle point. If we know that the game value lie between 1 and 2, the game value for this game will also lie between 1 and 2. All right, then what precisely is the game value, or what precisely is the game value, and what will be the strategy for player A and player B, will be seeing that sometime later. Okay, so for seeing some more things in game theory, let's wait for second lecture. So we'll be stopping here, right? In second lecture, we will be solving the game if the game doesn't have saddle point. Okay, I'll be gradually drowning you by be taking first very simple matrix 2 by 2, then we'll go to m by 2 or 2 by n. Okay, then we'll be going to 3 by 3, and then we'll be learning general methods of solving the game. So let's stop here. Okay, thank you.